Yeah, hello everyone, myself Maruti, welcome you all to this physics video session. In this video, I have taken a topic from atomic structure. In the same way, how the electrons are filled in the atom, right? That is the topic. Of course, we know that there are three principles helping us to make it clear how the electronic configuration should be done. Right, the first one is Pauli's exclusive principle, the second one is Aufbau principle, and the third one is Hund's rule. These three principles are letting us know how the electron should be filled up, right, in the orbits or in the orbitals. So how it is going on? So in my earlier video, I have already explained you regarding Pauli's exclusive principles, what are the rules to be followed while filling up. Now in this video, I'm going to tell you regarding right, it's nothing but Aufbau principle. Let's come back to this one. What does Aufbau principle say? Right, how the electronic configuration should be filled, what are the rules it has to be followed, what is the principle? See here, electrons can be built up by placing electrons in the lowest available orbital in the order of increasing energy. This has to be stressed on more. Right, this is the point what we are saying. How the electrons are filled up. Right, electrons can be built up in placing electrons in the electronic configuration can be built up. We can take it here. Electronic configuration. Electronic configuration can be built up by placing electrons in the lowest available orbitals in the increasing order. That is what. Now let's get back to this one. So we are having orbit here, the first orbit. We are having second orbit here. How the electrons should be filled? What is the serial order means? He is talking about increasing energy, right? In the order of increasing energy means the smallest orbit which is having least energy should be filled first. Later on the next one, later on the next one. That is the concept what is saying. For example, we are having two orbits here, first orbit and the second orbit, right? So which orbit should be filled first, right? The orbit which is having least energy should be filled first. That is the concept he has given. Not only that, that is the general idea, but there are certain rules saying on this one. So here if you observe, in the first orbit as it is in the K, principal quantum number is 1, we will be having 1s orbital. In the same way, if you go to the second orbit, as n is equal to 2, we will be having this as a 2s and this is 2p. In the same way, we continue with orbits and orbitals, shells and subshells. What is the rule it has followed? This is the general. So what is the rule it is following? Order of increasing energy. Electronic configuration can be filled on, right? How the electrons should be filled means in the order of increasing energy. So right, okay, this is the rule what it is followed, accepted for that one. But how many number of electrons are there in each orbit? That is also a rule laid down here. We should know how many can be filled. Why? Because of the increasing of the atomic number, new electrons are added. As many as electrons as the atomic number is. If the atomic number is 11 electrons will be there. If the atomic number is 20 electrons will be there. So, right, that's what we are seeing. As the atomic number, those many number of electrons. So, where does this electron go? How many does it go in each orbit? How many does it go in each orbital? That's the important thing we should know. So, for that one, a rule is laid here, right? A maximum occupancy of electrons. So, in each orbit, this is the formula given for us. It is nothing but 2n square. Maximum number of electrons can be adjusted in each orbit is given by the formula 2n square. Now let us take with the K orbit, the first orbit. We know the principal quantum number n is equal to 1. Just now I have given to you principal quantum number. And what is the formula it is giving? It is nothing but 2n square. If you plug in the 2, right, in the place of n 1 square, it is nothing but 2 into 1, which is nothing but 2. Means how many electrons can be there in the first orbit? In the first orbit, we are having 2 electrons. The maximum electrons can be adjusted in the first orbit is nothing but 2. Alright, in the same way, to know for L principal quantum number is 2. In the same way, 2, if you plug in the formula 2 into 2 square, which is nothing but 2 into 4, which is nothing but 8. Right, 8 electrons can be adjusted in the second orbit. So how they are 8, I will let you know. In the second orbit, in the 2s orbital, we are having 2 electrons, that is 2, plus in the 2p, right, we can adjust 1, 2, 3, 4, 5, 6, totally 6. That's nothing but 8 electrons. Right, totally. That is nothing but 2 plus 6. So this is the rule what we are saying. Now if you go for the m orbit, the third orbit, n is equal to 3, the same formula, 2 into 3 square, which is nothing but 2 into 9, 18 electrons can be adjusted in the third orbit. We can go over that one. So if n is equal to 4, that is KLMN, so which is nothing but 2 into 4 square, which is nothing but 2 into 16, which equals 32. So this is the maximum number of electrons which can be adjusted as the atomic number is increasing. 2, 8, 18, 32. We have to remember this one. Now this comes in the place of orbits. This is nothing but the orbit. Right, orbit occupancy, this is what? In orbital, that is nothing but subshell or the suborbit. How many number of electrons, maximum number of electrons which can be accommodated in each subshell? Let's go with the formula here. L, we are taking azimuthal quantum number, which is nothing but L represented with L, and as it is subshell yes, it is nothing but L is equal to 0. And the formula what we are getting is in each subshell orbit, the formula is 2 into 2L plus 1 is the formula. So if you plug in with the formula 2 into L value we are getting it as 0 plus 1, which is nothing but 2 into 0 plus 1, which is nothing but 2 into 1, which is nothing but 2. That is what? In each s orbit, how many electrons are there? There are 2 electrons. Maximum number of electrons in the s orbital is nothing but 2. In the same way, if you go for P is equal to L is equal to 1. If you plug in 2 into, it's nothing but 1 plus 1, which is nothing but 2 into 2 ones 2. 2 plus 1, if you plug in there, 2 into 3, which is equal to 6. Therefore, 6 number of electrons. How? I can explain it for you. 1, 2, 3, 4, 5, 6. Totally 6 electrons can be adjusted. In the same way, if you go for D, whereas L is equal to 2, we can directly say totally 10 are there. Why? Because 2 2's 4, right? 4 plus 1, 5, 5 2, 6, 10. In the same way, if you go for F orbital, we can straight away say it's nothing but 14. 14 number of electrons can be adjusted in B maximum. Just now we said it is nothing but 10, and the AF it is nothing but 14, whereas S just now we said it is 2, whereas P is nothing but 6. This is the maximum occupancy of electrons in the subshell. These are the two rules, but there are many rules which says how the building of principle, how the electrons are built in the orbit and the subshell. Shell and subshell is given by two principles. We'll get back. Yeah, what does the Aufbau principle say? How it has to be filled? Rule 1. I'm going to the rule 1. Right. Electrons are assigned to the orbital in the increasing value of n plus L. This is the rule 1. Electrons are assigned to the orbital in the increasing value of n plus L. That is the rule here. Right, this is the first, according to Aufbau principle, this is the first rule. Whichever is having least n plus L value, that has to be filled first. Right, you know what is the meaning of n? It's nothing but the principal quantum number. Right, and L is nothing but the azimuthal quantum number. Whichever orbital is having less n plus L value, that has to be filled first. Okay, now let us take two orbitals as an example. I have taken 4s and 3d. According to the rules, third orbit should be filled first, later on the fourth. Why? Because third orbit comes first, later on fourth. If you go for the structure of the atom, nucleus, first orbit, second orbit, third orbit, and the fourth orbit. General knowledge says, first fill 3D, then go to 4D. This is the general rule, but it matters. What does Aufbau principle, how it has to be filled up? Let's go for this one. So let's explain this one. So here, let us take 4s. Energy level, I have taken it as 4s. Right. In this 4s, what is the shell what we are using? Which shell? I am talking about this one. I am talking about this one, 4s. So 4 means the orbit. So n is equal to 4. As it is K, L, M, N shell. N is the shell and the principal quantum number is 4. for 4s. By seeing this 4, we can say principal quantum number is 4 and the shell is 4. Fine. Now, what is the subshell we are using? It's nothing but the s, and azimuthal quantum number is nothing but 0 here. Right? So I repeat, energy level we are talking about 4s. By seeing the principal, I write 4, it's nothing but KLNN. N is the shell and the principal quantum number is 4. Cool. Now let's go for the subshell. By seeing this S, we can say the subshell is L, and we denote with azimuthal quantum number. For azimuthal S orbital, the azimuthal quantum number is 0. Now, if you check it out, n plus L value means 4 plus 0, it's nothing but 4. What is the n plus L value of 4s? It's the 4s. N plus L value is nothing but 4. Cool. Now let's get back to the 3D. Let's get back to 3D now. Right. Now by seeing 3 here, it's nothing but KLM. Right. N is equal to 3. It's fine. And it's nothing but the M shell. Okay, here itself he is saying it's nothing but D, right? S0 SPD. L is equal to 2. L is equal to 2. For D suborbit, principal azimuthal quantum number is 2 now. So it's good. Now let us find n plus L value. It is nothing but 3 plus 2, which is nothing but 5. Okay, for 3D, so what is the n plus L value? For 3D, n plus L value is nothing but 5. The 3D which is in the third orbit, the orbital 3D is in the third orbit, whereas 4s is in the fourth orbit. According to the common thing, we think that 3D should be filled first and later on 4s should be filled. But here if you check it out, the n plus L value of 4s is less. This is less. This is more. Is it cool? So which should be filled first? According to the rule. First rule, n plus L value increasing first to the lowest. Right? We have to think here. Right. 4s has, right, less energy. Or we can straight away say n plus L value. N plus L value than 3D. So 4s has less energy than 3D. Okay, right, less n plus L value. So which should be filled first? Therefore, 4s should be filled first. 4s should be filled first. This is the rule. Filled first. Then 3D means, according to the rule, 4s should be filled. 4s should be filled first. After filling 4s, then get back to 3D. Here it has to be filled with electrons. That's the rule. Rule 1 says, according to minimum n plus L. Yeah, as the rule 1 says, right, electrons are assigned to the orbital in the increasing order of n plus L value. That is the rule 1 says. Then we come across a doubt, right? If two orbitals are having same n plus L value, then what in that case? I repeat, rule 1 says that we have to fill the electrons in the increasing order of their n plus L value. Now, the second point raises, if two orbitals are having same n plus L value, then which orbital should be filled first? That is the question. For that, Aufbau principle has given a logic for us. That is, if two orbitals are having same n plus L value, then the orbital which is having minimum n value should be filled first. Principal quantum number, n value, whichever is having less, that should be filled first. To explain this, let me come out with an example. Let me take 3D and 4p. We have taken 3D is the one orbital and 4p is the other orbital. You know, 3D means we are filling in the third orbit. 3D is the orbital present in the third. We know the n plus L value, that is in the third orbit, and the suborbital is nothing but D. Now let us go for 4p. 4p means it is present in the fourth orbit and the orbital is p. So which has to be filled first? 3D or 4p? Now first let us check the n plus L value of that one. So if you go back to this one, so the first one is nothing but 3D, right? The shell, as we are seeing, KLM. M is the shell. As M is the shell, principal quantum number is nothing but the 3. That is the point 1. Now let's go for the subshell. Subshell here it is clearly said it is nothing but D subshell. Now D subshell means we go with azimuthal quantum number denoted with L. SPD, it's nothing but 2. Okay, for L it is 0, for P it is 1, for D it is 2. Now what is N plus L value? N plus L value, 3 plus 2 is it nothing but 5. So the N plus L value of 3D orbital is nothing but 5. Cool. Now let's get back to the 4p. It's nothing but 4p. Now by seeing itself, right, fourth orbit K, L, M and N. N is the orbit. And the principal quantum number is nothing but 4. Just now we have seen that. And what is the subshell? It's nothing but the P. For P, just now I said it is L is equal to 1. Okay. Now what is N plus L value? That is 4 plus 1, which is nothing but 5. Okay. Now if you check it out, right, they both N plus L value are equal or same. Now the question arises, according to the first rule, if whichever is having less N plus L value should be filled first. But they both are having same N plus L value, both are 5 and 5, which has to be filled first. That is nothing but the second principle. Whichever is having least N value should be filled first. So here if you check it out, the least N value is given to 3D. Therefore, 3D should be filled first. That's what 3D orbital is having least N value, that is principal quantum number. Therefore 3D is filled first, then 4p. This is the rule. So this is nothing but the second principle. Yeah, now following the procedure of Rule 1 and Rule 2, right? How the orbits and orbitals are filled in the atom. So we are having different orbits K, L, M, N, right? N is equal to 1, 2, 3, 4, and we have S, P, D, F, right? So what are all the orbitals what we have? We have arranged it here. So 1s, 2s, 2p, 3s, 3p, right? We have arranged it. But how they are getting filled? To make you better understand, a diagram called Muller diagram has been given, introduced by scientist Muller here. So he has given you a systematic diagram to explain you how the orbitals are filled with following all the rules. Rule 1. N plus L value increasing. Second one, if two orbitals are having same N plus N value, the orbital which is having minimum N value should be filled first. By following those two, what is the procedure? It is filled in the orbit. Let's go with the diagram. Now, so if I take 1s as if we know here, 1s, right? In the same way, if you go here, so N is equal to 1, it's nothing but first orbit, it is K, 1s, we have only one orbital. In N is equal to 2, the second orbit, we'll be having two orbitals, 2s and 2p. In the same way, N is equal to 3, it's nothing but K, L, M orbit. We'll be having 3s, 3p, 3d. If N is equal to 4, we have 4 orbitals. If N is equal to 5, we have 5 orbitals and so on. But what is the procedure? By following the rules, he has given a diagram for us. So it is like this. First, while getting down, you go through that 1s, and while coming back, you come back from that gap. Alright, so we are coming back, again it is filled. So according to the rule, first 1s should be filled first. It's 1s, right? N plus L value is more, right, for 2s than 1s. So 1s is filled first, later on 2s is filled, later on I'm coming back from the gap, and again while going 2p and then 3s. So after 2p, then 3s. Yes, I came. While coming back, you come back from that lane. Later on, we filled 3p. It's 3p is having more. After 3p, 4s. Yes, after 3p, 4s. After 4s, come back from that gap. Again, follow this one. 3d, 4p, 4s. It's nothing but this. We are filling with this one. Right. So after 5s, get back, and again 4D, 4P, 6S, right? 4P, 6S. This is the order what we are going to follow. Right, but as we all know, for all the s orbitals, azimuthal quantum number is 0. For all the p, L is equal to 1. For all the d, L is equal to 2. For all the f, L is equal to 3. Now the only logic what we have to remember is, while drawing the diagram, first orbit as n is equal to 1, you go with 1s. If n is equal to 2, go with the 2. N is equal to 3, go for 3. N is equal to 4, go for 4. Of course, we have many, but no need of. Why? Because we don't have those many elements. We are having only 108. By here, we can fill it up. If new things are introduced, then we can extend the diagram. But here, so fill out like this, but while going, go through that number while coming back, come from the gap, then you continue. This is the diagram showing us how to fill the electrons in the increasing order. Of course, this is given by Mr. Muller. All this comes under Aufbau principle, which is also called as building up principle. Thank you. In this channel, I have been placing both math and science videos.